Howdy, howdy. Okay, so last video that I put out, we talked about the fact that when we multiply exponents, so x to the fifth times x to the seventh, x to the seventh, that we just add the exponents. So when we're multiplying variables raised to an exponent, or anything actually raised to an exponent, so this would be equal to x to the 12th. So we just add them. 5 plus 7 is 12. Well, if that's what we do when we multiply, I briefly talked about the fact that in order to divide, we're going to just subtract the exponents. So in this one here, if I have x to the ninth over x to the fourth, this is equal to whatever the top one is minus the bottom one. And you make sure you do that because, well, we're going to be talking about situations where the bottom one is bigger later on. In fact, I'm going to do one or two of them here in this video. So this is equal to x to the fifth. Now, some people say, well, I don't quite understand these rules and how they happen. So I'm going to very quickly show you what this really means in terms of exponents. And so let's take a look at that multiplication problem up top first. X to the fifth means x times x times x times x times x. There's 5 x's being multiplied together. And no, this is not 5x. That would be 5 times x. This is x times x times x times x times x. Okay? And then x to the seventh, so then it's times x to the seventh, which is 1, 2, 3, 4, 5, 6, 7 of them. So how many x's do I have all together? Well, I have 12 of them, so that's how we ended up with x to the 12th. Okay, the same kind of deal applies here with the division. I've got x to the ninth. 1, 2, 3, 4, 5, 6, 7, 8, 9 on the top or in the numerator. In the denominator, we've got 1, 2, 3, 4. Now, since this is all multiplication, we can cancel. We can reduce by canceling, because each time we cancel, it's just equal to 1. So I go, okay, I'm going to cancel, I'm going to cancel, I'm going to cancel, and I'm going to cancel. Well, let's see. That's 1, 2, 3, 4, 5 on the top. So x to the fifth. And you could say x to the fifth over 1, but that's just extra talking. So it's just x to the fifth. It's kind of like saying, well, going to Burger King and saying, I want 3 over 1 cheeseburgers. Well, that would just sound really, really weird. That's just 3. Okay? So this is the basics to this. Let me show you a couple more division problems. The first one I want to show you is one where we also have coefficients. So let's say I'm going to do 12x to the fourth over 4x squared. All right. Now, again, I can write this out the long way. And if I wrote it out the long way, then I'd say, okay, this is 12. And then 1, 2, 3, 4 over a 4. And then 1, 2. Now, the x part here is really easy. You just cancel, cancel. And so it looks like we have 2 of the x's, so that's x squared up top. The part here that people kind of get confused is because we're talking about subtracting the exponents, people think that we need to do that with the coefficients as well. No, the coefficients are just being reduced just like they normally would. If I came up and just said, hey, take 12 fourths, figure out what it means. 12 divided by 4, that's what it means. And 12 divided by 4 is just 3, or 3 over 1. So we could say this is 3 up top over 1, and then put the x squared up top, which again is just equal to 3x squared, because it's a 1 in the denominator. Now, let's take a look at one where we end up with something other than a 1 in the denominator. We could have situations like this. How about 15x squared 3x to the 5th? All right. So again, I can sit here and write it out the long way. And writing it out the long way is 15 over 3. And then an x, and 1, 2, 3, 4, 5 x's on the bottom. We're going to reduce, and then 15 over 3 reduces to, let's see, they're both divisible by 3. So 3 goes into 15 5 times, 3 goes into 3 1 time. So on the top, we have 5. On the bottom, or the denominator, we have 1x to the 3rd. Now, do we really need that 1 there? No, we really don't. And in fact, it just kind of makes it look cluttered having the 1 there. So the answer that I would write is 5 over x to the 3rd. Okay. We can have it the other way around as well. So if I gave you something like 4x to the 4th over 24x. Okay, that's going to be reduce the 4 and the 24, so 4 goes into both of those. Let's see, so 4 goes into both of them. So 4 goes into 4 1 time, and 4 goes into 24 6 times. And then the little rule that we said as far as exponents when we're doing division is that we are just subtracting. Well, there's no exponent on this one on the bottom, so it's actually just a 1. I'm just not going to write it there normally. So that means we end up with x to the 3rd. Now again, I could just write out 4 x's on the top, 1 x on the bottom, cancel them. That leaves 3 of them up top. And this is the way it's going to look. Now again, do I need that 1? No. So I can just go x to the 3rd over 6. Last example. The last example is that we can do this with not only coefficients, but we can do this even with multiple variables. In fact, as many variables as we really want. So I'm going to show you what a real good problem or a bigger problem would look like. So maybe something like 10 x to the 4th, y to the 3rd, z squared, all over 2x y squared z to the 4th. Okay, now we can do this just with the rules, or we can actually write this all out if we're confused. I'm just going to show you writing it all out just the first time. So let's see, that's 10. 1, 2, 3, 4. 1, 2, 3 y's, and then a z and a z. And then on the bottom, a 2x, y, z, 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 z. And you're probably going, why is he putting the little line through the middle of the z? Because in math, if you don't put the little line through the middle of the z, it makes it look like a 2. And it's very easy to confuse. So now I can start canceling. Let's see, a 2 goes into both of these. 2 goes into 10 5 times. 2 goes into 2 once. I can cancel one x, I can cancel two of these y's, and I can cancel two of the z's. What's left over on the top? 5 and x to the third, one of the y's. Let's see, the z's are all gone off the top. And on the bottom, there's just a 1 and two of the z's. And that is it. So it's pretty easy to do, especially if we write it all out. But even if you wanted to use the shortcut, which I, strongly recommend, the shortcut is just knowing that we can subtract the exponents. So again, we still reduce the 10 halves, which is just 5. And then 4 minus 1 would give us x to the third. 3 minus 2 gives us the y to the 1 power. And then you're going to have 2 minus 4. That's going to give us a negative 2. And so that means that we actually, the negative part says, put it on the bottom. Sort of. We'll talk more about that later. But in this case, it says, put it on the bottom and make it positive. And that's all. Okay, folks. I will see you in class. Bye-bye.